It's Dr. J, and today we're talking about formula mass. So formula mass is the average mass of a molecule of a compound. So basically this is the sum of the atomic masses of all atoms in your chemical formula. So for instance, if we wanted to find the formula mass of H2O, right, that's just simple water. Okay, we're going to have to do a couple different things as far as looking at our periodic table, but then also looking at our chemical formula. So the formula mass is going to go like this. Basically, you're going to take your chemical formula, right? So in this case, I have H2O. So in our formula mass here, this is our 2 from our subscripts with our hydrogen. So this is letting me know I have 2 hydrogens, as well as my 1 AMU. Now, Dr. J, where did this 1 AMU come from? The periodic table. That is where it comes from, okay? So this is letting me know the mass, the atomic mass of my hydrogen. Hydrogen has 1 AMU. If you look on your periodic table, you'll find it right there. Now, from here, right, with formula mass, this is the sum of the atomic masses of all atoms in the formula. So, right, I got my hydrogen. What about my oxygen? So now we're just going to add my oxygen as well, which in this case, because oxygen is literally by itself, so it's just 1 oxygen, we're not going to put a 1 here, right, to be redundant. So I'm just going to have my mass right here for my oxygen. And if I look towards my periodic table, I'm going to see that oxygen has 16, right, for its atomic mass. So that's 16 AMU here. Now we add up our 2, because 2 times 1 plus our 16, we're going to find that the formula mass for water is 18 AMU. Now, what I want to go over quickly is molar mass. So we mentioned molar mass before in our moles video. Make sure to go look at that other video about moles. You want to understand moles for sure. But when it comes to molar mass, we need to understand that molar mass means that for every 1 mole, right, it is equal to that compound's mass. So for example, if we're looking at water's molar mass is for every 1 mole of water, there's 18 grams, right? And we know it's 18 grams because we just did the formula mass. So this is how we're going to be going about using molar mass going forward, right? We need to understand this conversion factor here, right? This is just another conversion factor. 1 mole equals a certain amount of mass, okay? So in this case, if we got water, 1 mole of water equals 18 grams. Now let's do an example here. How many molecules are in 5 grams of water? Okay, so what are we doing here? Dimensional analysis, right? So first thing we want to start off with is our given. 5 grams of water. So that's what we're given here. Now from here, what do we have to do? What are we thinking? All right. Of course, you know my routine. Feel free to pause me and try this example out on your own. Now let's get to it. So let's talk about this one. How many molecules? That's a little trick right there, right? So let's start off with our given. 5 grams of water, H2O. That's what we have here. Now I'm going to convert my grams. What am I converting my grams to? Moles of water. Okay, I'm going to convert it to moles of water. The reason being, I'll explain it in 2 seconds here. But let's talk about converting grams to moles, right? If we remember when we convert grams to moles, we have to understand that we always must use our molar mass. So in this case, our molar mass is 1 mole of water equals 18 grams of water, right? This is our conversion factor we just went over here, right? So now I'm going to place my 18 grams of water on the bottom. What do we notice? Grams of water cancels out. And I'm left with moles of water. Okay, so that's good. Now, why is it good to have moles of water on top? Because it's asking for molecules, all right? This is molecules. So because it's asking for molecules, we have to think about something. What are we thinking of, right? If it's asking for molecules or atoms or something like that, a particle, Avogadro's number. Avogadro's number, if you remember, 1 mole equals 6.022 times 10 to the 23. Always the case, okay? Always the case. So in this case, it's asking for molecules, right? We need to understand that these are molecules of water, right? More than 2 atoms, okay? So, right, we just set up like a normal dimensional analysis problem. 1 mole of water here, I'm going to put my 1 mole of water there. That's canceled, gone. Focusing on those units first, right? And then from here, right, H2O molecules, right? Avogadro's number is going to help me get to my molecules part. And I know that Avogadro's number, 1 mole equals 6.022 times 10 to the 23. So this is why we have it on top here. So now my grams are canceled, my moles are canceled. I'm left with my molecules on top. And then we just do our math, right? And if you remember, right, the little hint I've been giving out, you want to multiply straight through, then divide top by bottom, right? So we have 5 times 1 times 6.022 times 10 to the 23. That number on top divided by 18 times 1. And when we do our math here, we're going to see that we get 1.6 times 10 to the 23 water molecules, all right? So this is how we're going to go about using formula mass.